With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
As shown, a piston chamber of cross-section area A is filled with ideal gas. A sealed piston of mass m is right at the middle height of the cylinder at equilibrium. The friction force between the chamber wall and the piston can be ignored. The mass of the rest of the chamber is capital M. The atmospheric pressure is P naught. Now slowly pull the piston upwards. Find the maximum value of M such that the chamber can be lifted off the ground. The temperature remains unchanged. So this is the initial state. So in the initial state, let's say the pressure of the gas is P1. So P1 times the area of piston A should be equal to the pressure from upwards. The force from upwards, which is the mass of this piston mg plus the atmospheric pressure P naught times A. P naught A. So P1 is equal to mg plus P naught A by A. Let's mark it as equation number 1. Now, the question says that we are slowly pulling the piston upwards. So, if we are slowly pulling the piston upwards, that means eventually we reach the complete height, that is h. So, the piston reaches somewhere here. Now, if the pressure of the gas at that time is P2 and the temperature was constant, that is, it remains unchanged, so P2 V2 should be equal to P1 V1, which means P2, now volume can be written as area times H is equal to P1 area times, it is said in the question that the piston is in the middle of the cylinder, so P1 times A times H by 2, which means P2 is equal to P1 by 2, which means P2 is equal to mg plus P naught A by 2 by 2A. Equation number 2. Now, when the piston is at this height h, means when the piston is at this location, then the upward force that we are applying, so this is your piston at its maximum position. Now at this time we are applying some force F to lift this entire system up. So if I do the free body diagram for just this piston, what are the forces acting on it? So there's this applied force that we are applying F. There will be its own weight pulling it down mg. There will be pressure from the gas P2, and there will be atmospheric pressure P naught times A. Sorry, this will be, we are counting forces, so P2 times A. P naught A. So F minus P2, F plus P2 times A should be equal to mg plus P naught times A, which means F is equal to mg plus P naught times A minus P2A, which is equal to mg plus P naught A minus, what is P2? P2 is mg plus P naught A by 2A, mg plus P naught A by 2A times A. A and A get cancelled, so I get mg minus mg by 2 plus P naught A minus P naught A by 2, which is equal to mg plus P naught A by 2. So this is the force. Mark it as equation number 3. Now let's do the free body diagram for the entire system, that is the piston and the chamber. So let's say this is your chamber and this is your piston at its maximum height, and so if we talk about the forces that are acting here, the first force is the force F that we are applying to pick this system up, that is F. Then there is the force due to the pressure of the atmosphere, P naught A, acting downwards. There is the weight of this piston, mg, acting downwards. There is the weight of this chamber, mg, which is acting downwards. There will be the force due to the atmospheric pressure acting upwards, P naught A, and there will be a normal reaction due to the ground. Now, the condition, that is the entire system is picked up, in that condition this normal force should be 0. So let's write the equations. So the forces that are acting upwards are F plus N plus, now this P naught A and this P naught A are equal and opposite, so they will get cancelled, so I don't need to mention that. So all the forces that are acting upwards are F and the normal reaction. This should be equal to the weight of the piston plus the weight of the chamber. Now, as I said, in the condition that this entire system is in the air, this normal reaction will become 0. So this becomes 0. So I get F is equal to mg plus capital mg. Now I can put the value of F from equation number 3. So mg plus P naught A by 2 is equal to mg plus capital mg, which gives me mg is equal to mg by 2 minus mg plus P naught A by 2, which means capital M is equal to P naught A minus mg by 2g. So this is the maximum weight of the chamber. So the correct answer is option number B, P naught A minus mg by 2g.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.